Hi everyone. So here I'm going to tell you about how I sort of royally screwed up in the same way for part B and C of the pendulum experiment. Now you might be wondering how I figured out I had screwed up. Well, I was actually analyzing the same data that you were going to analyze, and I had taken my hex counts and converted them to decimal and worked out ostensibly what the measured periods were. However, what I was finding was that there was a huge difference of frankly almost it was actually larger than a factor of two, between the experimentally measured periods and what I was predicting with either the small angle or the all angle model. At that point, I started to think about what might have happened. So I started to think about, well, did I screw up measuring the length of the pendulum? Well, and that was like, well, I did it a whole bunch of times, and that doesn't, there's probably some systematic error in, me not holding the meter stick perfectly straight each time, but it's hard to see how, since the period goes roughly like the square root of L over G, to be off by a factor of 2 in the period, I'd need to be like off by a factor of 4 in the length, which just doesn't seem plausible. The odds of little g having magically changed in CNS 204 also don't seem very likely. So it became apparent that what probably got screwed up was the period measurement somehow. So my first thought was, well, did I misread the period? Well, here's where I'm glad I had the function generator hooked up to an oscilloscope, because it was very clear that the clock frequency was in fact 4 kilohertz. I then started watching the video, and eyeballed the period measurement with a stopwatch. To help me measure it better, I counted something like 3 swings. It's easier to time longer time intervals with a stopwatch, so I just watched for like 3 swings and then divided the time I measured by 3. And that's how I figured out that I did the following. So how I goofed up was the counters overflowed. So when I eyeballed the video, it turned out I was getting a period of around 1.8 seconds. Now I had the clock frequency set at 4,000 hertz the entire time, and if you're trying to measure 1.8 seconds, well, if you've got 4,000 clock periods per second, 4,000 counts per second, you're going to get, with 1.8 seconds, 1.8 times 4,000 equals 7,200 counts in decimal. However, remember that we only have a 12-bit counter. We can only count from 0 up to 4095, and then the counter rolls back over to 0. This is what got me. I forgot about this. I should have done a plausibility check of my data. I would probably have told you to do the same thing. Would have, or done a quick back of the envelope calculation to make sure that the frequency I had picked would not cause an overflow. But I wasn't. I got a little sloppy, and that's what happened. Fortunately, what so what there is a way to fix this. So we simply just need to add 4096 decimal to our raw measured counts. So by raw counts, that's what I posted in that PDF on Sakai. Just to convince you that this is in fact the case, just to work through an example, right? If I measured actually 4096 counts, right, then my counter would have rolled over back to 0. At 4097, right, my counter would have gone up to 1. I would have rolled back over and then counted up to 1. So to get the actual count, I just add 4096. And how I know that that's, that it only overflowed once and not several times, well, this is where the eyeball measurement of the period with a stopwatch comes in. Um, the period, is not 1.8 plus another roughly second. So given that there's only sort of one overflow scenario that's remotely consistent with the measured data, I think we can identify that as what happened. So yeah, so that's how I messed up. Whenever I got in trouble as a kid, my younger brother would always say to me in a very self-righteous way, "Let this be as a lesson unto you." Well, let me say to you that yeah, this is sort of a lesson for all of us, myself included. So yeah, this is a case of yeah, I got a little sloppy, so in a little bit of a rush. Um, and this is why it's always worthwhile to plausibility check your data and your measuring devices. Fortunately, this mistake was one that we could figure out and recover from. So the data I took are still useful. But yeah, I guess the other point is that I think I've said this to people in my classes before, but we all make mistakes, myself included. I'm trained as an experimentalist. I think I think of myself as a competent physicist, but yeah, I totally goofed here, but that's okay. I mean, because it happens to the best of us, and what one just needs to do is to think about how to move forward, maybe in a creative way. All right, so hope you had fun thinking about this, and so I look forward to seeing your data analyses and reading your lab write-ups. Take care. Bye now.